Do you know how the Earth is moving? Or even the other planets? Or how the Earth moves in orbit around the Sun? Well, you will find the answers of all these questions that runs in your mind right now. In Do You Know? Do you know how the Earth do its motion? Well, now the two motions that we're going to talk about is a rotation of the Earth and the revolution of the Earth around the Sun, so let's get started. The first motion that we're going to talk about is Earth's rotation. Now Earth's rotation is defined simply as the spinning of the Earth on its axis, so you can see the rotation of the Earth right here. All you see is the Earth just spinning in place around this imaginary line that runs through the middle of the Earth at a 23.5-degree angle called its axis. And usually we identify the top of the axis with the North Pole and then the bottom of the axis with the South Pole. And as you can tell, that central line is the line that cuts you in the middle as the Earth spins. Now it takes a certain amount of time for the Earth to complete one spin, and that's called the period of rotation. If you have trouble remembering that, think about your class periods or chunks of time designated for certain subjects. So period 1 is a 40-minute block of time for one subject, and period 2 is another designated block in time for another subject. Well, your period of rotation is a block of time for the Earth to spin once, and we could describe it several different ways. It actually takes your 23 hours 56 minutes and some change in seconds to complete one rotation. However, we round that up to 24 hours because it's easier, and as we know, 24 hours is equal to 1 day. So it actually takes the Earth 1 day to complete one. So when the calendar switches over from Monday into Tuesday, the reason why it goes from Monday to Tuesday is because the beginning of Tuesday marks one complete spin of the Earth. And then Tuesday to Wednesday is another complete rotation of the Earth, and then Wednesday to Thursday is another one, and the Earth will have 365 1/4 rotations in a year. If you take a look at this here, you'll notice that the Earth spins in a particular direction, and you'll also notice if you look that the land masses start from the west. So you could probably tell that the direction of the rotation is from west to east. And if you take a look at this rotation from above the North Pole, you'll see that it goes in a counterclockwise direction. Now the rotation of the Earth is going to affect the path of the Sun across the sky, and that affects where the Sun rises and the Sun sets. So because of this counterclockwise west to east rotation, our Sun is always going to rise in the east and then sets in the west. Let's take a peek at how that looks on Google Earth. So let's start out with some basics here. The bright half of the Earth is in daytime, so because it's getting the sunlight from the Sun. The dark half the Earth is nighttime because it's getting no light from the Sunday. So currently the United States is at nighttime, and then you have Europe and Asia in the daytime. Now the Earth, remember, rotates in a counterclockwise direction, so it moves in this direction here. Keep an eye on the eastern coast of United States as the Earth rotates in its counterclockwise direction. You're going to notice that the eastern coast of United States is going to get to the sunlight first. This is going to give us the apparent motion of the Sun rising in the east and starting to move across our sky. So why does the Sun rise in the east? Simply put, because the eastern part of the country is going to get to the sunlight first, and as a result that Sun is going to rise and then move across our sky. As the Earth rotates and spins in front of the Sun, and now we are in the daytime, and as we continue to rotate, it's going to the Sun will move across our sky even more and start setting into the western part. And the reason why it appears you set in the west is because if you take a look as the eastern coast renders nighttime, the last bits of sunlight are located in the western portion of the United States, giving us the apparent motion that the Sun is setting in the west, and eventually they will catch up and then be a nighttime again, so that's why the Sun appears to move through our sky. Now this is what it kind of looks like throughout the day. If over here on the right is the east and then over here on the left is west, our Sun will rise up in the east and then get to a peak point at about noon in this area, and then start to seep back towards the west, so we have that apparent motion all right, so that's rotation of the Earth. Now let's talk about the evidence to help prove rotation of the Earth. There's two pieces of evidence that we're going to discuss. First piece of evidence is our star trails. Star trails are these circular trails that the stars leave when exposed or overexposed to a camera. The reason why the stars leave these trails is because throughout the night, even though we can't see it, The stars actually appear to rotate in the sky above us, however it's not the stars that are actually moving, it's actually the Earth that's moving underneath the sky. So as the Earth spins underneath the sky, these stars appear to spin in our sky basically like this. If you were to stand up right now and look at your ceiling, and then start to rotate in place, your ceiling will appear to be spinning above you, but as you know, the room is not actually spinning, you are spinning underneath the ceiling, so your rotation in place gives a ceiling in an apparent motion of rotation. That's the same thing that happens with Earth. The stars don't rotate around us in the skies, that the Earth rotates underneath the sky, giving our star trails here. Now a second piece of information or second piece of evidence to help prove. This is what we call phone calls, pendulum phone calls. Pendulum was designed and set up in 1851 and was the first thing that really gives us any simple evidence that the Earth rotates, and all this pendulum does is swing back and it knocks down these pegs. We have an example of phone calls pendulum, so once I set this in motion, you'll see that the pendulum swings back and forth and the pendulum would hit about here. However, since the Earth rotates and the board below is the taps of the Earth, it's going to start to move. And you'll see that 30 seconds later, that the position of where the pendulum hits has now changed. It's no longer over here, it's slightly more to our left, and that's caused by the rotation of the Earth moving this board, and as the Earth continues to rotate, you'll know that is now touching the peg, and in about 90 seconds later after we started, this pendulum is going to come swinging, and it's going to knock down the peg, and the reason why that happens is because the Earth was rotating underneath the pendulum. If the Earth did not rotate underneath the pendulum, then the pegs wouldn't be knocked down. And that's Earth's rotation. So what we just take a quick look at what Earth's revolution looks like. Now Earth's revolution is a little bit different from the Earth's rotation, because Earth's revolution is not the spinning of Earth. That's the rotation the Earth's. The revolution of the Earth involves the movement of the Earth in its orbit around the Sun. So when you take a look, you'll see our inner planets Earth, Mars out here, Mercury, and then Venus, and then in the middle is the Sun. As you can tell, each planet has an elliptical type shape going around the Sun. And those are the planets' orbits. Here in the green is Earth's orbit, so this is the path that the Earth takes around the Sunday. So as a planet revolves around the Sun, it just simply moves around it. That's all, it's just traveling through space in its orbital path around the Sunday. Now our revolution or period or evolution is the block of time it takes for the Earth to go around the Sunday. It takes us 365.25 days to do this, or as we like to call it, 12 months, or we call it 1 year. So for the Earth to finish one complete revolution around the Sunday, it takes us 1 year. So you could think of it as New Year's. Whenever you celebrate it, you're celebrating a safe trip around the Sun, and then the beginning of a new one. And then lastly, the direction of revolution. As you can see, the planets are moving again in the opposite direction of where the clock hands would go. If this were a clock, so as a result the direction of our planets for revolution would be counterclockwise. To sum up Earth's revolution, it's the movement of the Earth in its orbit around the Sun. It takes us 1 year to do it, or 12 months or 365.25 days, and the direction just like everything else. So that concludes our lesson on rotation and revolution of the Earth. Till next time. And don't forget to leave a comment suggesting a new topic and subscribe to our channel to support us.